Have you ever wondered how geostationary satellites maintain their position in space, or pondered the concept of a space elevator that could transport us directly from Earth to space? These are fascinating questions that delve into the intricate and fascinating world of orbital mechanics and space technology. Imagine a satellite spinning around the Earth at an altitude of approximately 35,786 kilometers above the equator. This isn't just any satellite, this is a geostationary satellite. It orbits the Earth at a speed that matches our planet's rotation. This synchronicity allows the satellite to appear stationary relative to a fixed point on Earth's surface. It's an ingenious concept, one that gives us constant coverage of a specific area on Earth, making it invaluable for telecommunications, weather monitoring, and navigation. Now consider a space elevator. This isn't your average building lift, but a theoretical structure extending from Earth's surface into space. The top of this elevator would reach the same altitude as our geostationary satellites. A tether, potentially tens of thousands of kilometers long, would connect the elevator to the Earth. It would need to maintain its stability and tension, much like a geostationary satellite holds its position in space. And what about the force of gravity pulling everything back to Earth? That's where a counterweight comes into play. Just as geostationary satellites balance the gravitational forces pulling them toward the Earth with the centrifugal forces pushing them outward, a space elevator would require a substantial counterweight at its upper end. This counterweight would balance the gravitational forces and keep the tether taut. Geostationary satellites are more than just space-age counterweights, though. They are integral to our global communication networks, providing services such as television broadcasting, internet connectivity, and mobile communications. While a space elevator could offer an alternative route into space, our geostationary satellites currently provide the essential infrastructure for these services. Both geostationary satellites and space elevators, though serving different purposes, share common concepts related to orbital mechanics, stability, and positioning in space. By understanding the principles of geostationary orbits, we can better grasp the technical and logistical challenges associated with building and operating a space elevator. These challenges include the need for an incredibly long, stable tether and a massive counterbalancing mechanism. By now, you should have a better understanding of how geostationary satellites maintain their position in space and how these principles apply to the concept of a space elevator. Whether you're gazing at the night sky or dreaming of future space travel, remember the intricate dance of gravity and centrifugal force that allows these marvels of technology to exist. Remember the geostationary satellite spinning in sync with our planet, and imagine the possibilities that a space elevator could bring.